Hello everyone. In today's video, I would like to talk about Ralph loop, share my thoughts, the way how I understand it, and demonstrate a small prototype that I built based on the idea. First of all, let's talk foundations. What Ralph loop is in the first place. While I was recording and re-recording this video, actually the agent almost completed the feature, so I'm actually running out of material here. So when you're building with AI, in order to get quality results and actually multiply yourself, you really want to do proper planning. As a result of proper planning, you end up having a plan, a PRD, a specification. In my case, it is an epic in this task tracking system called Beats that I actually use most of the time instead of the Markdown. Overall, the idea behind the plan is not only for you to better understand what you're going to build, but actually provide comprehensive instructions for this big chunk of work for the AI agent, so that you don't need to steer the agent to continuously follow up and tell it what to do next. So to achieve that, you want to split your plan into phases, tasks, milestones, like you can use any name you want. What can possibly go wrong with this approach? If your plan is big one, so your feature is pretty significant, you end up with a big number of to-dos of tasks. And when your agent working on them will run out of context. We don't really want that. The way to mitigate the problem is to find a way for your agent to always start with fresh context. That's why, for example, in the recent update of Claude Code, it now tells you, hey, we finished planning, switching to the execution mode. Shall I clean the context? And this is where splitting your PRD, your plan into smaller tasks can help. There are multiple options available to you. Inside the plan itself, you can add a status field to each individual task, and when agent works through them, it just marks the ones that are already completed. So you start a new session, give it a PRD, and tell it, hey, find the task that is not yet ready and work on it. You can externalize the tasks, like create GitHub issues, for example, create maybe smaller markdown documents, a JSON file with the task, or like me, use beads so that actually you see each individual task is literally an individual task. And they form an epic, they have dependencies, and that's why some of the tasks can actually be blocked until some of the ones that are blocking them are actually closed. And this is essentially how the Ralph loop works, at least to my understanding. With the Ralph loop, your goal is to automate yourself out of this process. So you just give a PRD spec to your agent, apply the loop, and it works autonomously until completion. So you actually don't need to periodically steer your agent to, hey, please pick up a new task, cleaning the context, or, sometimes agent just stops without even asking for further instructions. It just stops. So Ralph loop is literally a loop. There are small iterations defined by a rather simple prompt depending on your project. And this prompt tells your agent, hey, please read my PRD, read the temporary progress file that we are creating while executing this feature, find one task that is ready for execution, claim it, work on it. Of course, for high quality code, you want some validations, like run the tests, LinkedIn, etc., to confirm that the task actually produced quality code. Then you tell the agent, when your task is done, please append the progress as a context for future iterations, commit all your changes, and be done with that. And then there is some harness like a bash script or whatever you build yourself, or like any other harness that you're using, that literally runs this in a loop. So it starts a new agent, a new session, clean context, sends your prompt and waits for the agent to finish. And then it runs again and again and again. Of course, you always want guardrails, like you want to define the maximum number of iterations. If your agent gets stuck and just runs indefinitely, you want to stop it and be able to reassess what's going on and not to burn too many tokens in the middle. When you're doing the classic Ralph loop that you can read on the internet, in the iteration prompt, there actually is one additional instruction saying that if there are no tasks for you to pick up, output some cryptic phrase that my orchestrator, my bash script, will see and treat it as the end of the feature, end of the loop. This is what was scratching my head. The best AI system is actually a deterministic finite state machine, or a deterministic workflow. The more determinism you can bring into your algorithm, the better. It will be the most accurate, the most predictable, maybe sometimes the fastest one. So you want to reduce the amount of AI as much as possible. And this is why I think Ralph Loop was born. We all know that when we are prompting AI, it really can stop mid-sentence, mid-task, like it can claim that it completed, but actually it did not. And so we add some kind of bash script that just, no, I don't trust you, I will run you again and see if your claims were true. And so while reading about feedback and experience from the members of the community about the Ralph Loop, I noticed an interesting pattern. For example, someone shared that the loop for this person stopped because the agent wrote, the tasks are not done, so I'm not going to output stop. And the bash script treated it as the stop and exited. So there is this still non-deterministic condition for finishing the work. And this sparked my interest and curiosity and made me build this tiny Ralph Loop prototype that I call Junior, where whatever can be deterministic is deterministic. Let me share my screen again. Okay, let me do a real quick assessment of the progress. It feels that it stopped. Maybe it already finished the feature. Let me take a look at the progress. Look, closed tasks can still have incomplete work. Always verify current state before assuming completion. I think that's a great example of the non-determinism. Had to reopen closed tasks to complete the actual migration. Task was previously marked complete. And the best one, look, Epic was closed prematurely, 37 remaining usages across other controllers. So that's really a great example. Okay, and so back to Junior. To test my idea, the very first thing that I did is pretty straightforward. Let me find the code. Here you are. The very first thing that I tried to extract from the prompt, from the iteration prompt, is the exit condition. So in my projects, I'm using Beats, the external task tracking system, which has a CLI tool. So my harness at any point in time can run it and to see if there are any open tasks, tasks in progress, or like if all tasks are closed. So instead of trusting the agent to output the complete word, the completeness marker and use that to exit the loop, the iterations. After the agent is done with the iteration, the harness just simply looks into the open tasks, and if all of them are closed, then we are done. Then there is another small thing that I figured out, and it actually relates to what I read from the progress from the terminal. Sometimes the agent stops midpoint, maybe without completing the task, or the task is complete, but it is not marked as done in the task tracking. So after the iteration finishes, the harness junior looks through all the tasks, and if there is anything in progress, this kind of invariant, there should be 0 in progress tasks after the iteration. So it just resets them back to ready. To summarize, there are plenty of improvements that we can build on top of this simple Ralph loop and actually over-engineer it. The very first obvious ideas that I explored is to validate that the feature is actually fully built by looking at the number of remaining tasks. And it is not coupled to beads or, the task tracking system that you use in your projects. If it's a PRD in a markdown file and you ask the agent to literally cross out the tasks there, you can just write a simple parser that checks if the task is crossed out or not. If you're using JSON or JSON lines, again, it's even easier. So it really doesn't depend on the tooling. So detecting if the feature is actually built, then figuring out if the agent stopped mid-task, it forgot to commit the changes, it forgot to mark the task as completed, you can do some cleanup and revert to a more predictable state. Another thing that I might explore later on is the actual validation of an iteration. So in our prompt, we always tell the agent, not in my prompt, we always tell an agent, run lint, run tests, run type check, and other quality gates. Again, an agent might forget to do that. So this is another thing that can potentially be extracted, and maybe after each iteration or every other iteration or at the end of the feature, your harness, the orchestrator, in my case Junior, can run all the validations, run all the tests, and if there is anything failing, then retrigger the agent and provide in a prompt hey, by the way, there is something off here, let's figure this out. So this is it. Thanks for listening, and see you next time.